Hello everyone, I'm Lakshmi Susritha and today I'm excited to present a project on the blockchain decentralized voting application. And here are our team members and our team name is Blockchain Builders. Next slide. Yeah, now let us go through the introduction. So in any democracy, generally voting is very incredibly important. It plays a very pivotal role in it. So it shapes the nation's future. And also as countries get larger and larger, using the traditional paper ballots becomes really complicated. So the paperwork is extensive and there is a risk of tampering and also there is a risk of rigging. So this is where the blockchain technology comes into picture. So it's a system that records transactions across a network of computers, creating an unchangeable chain. And also blockchain's key features like decentralization, immutability, and transparency make it a great solution for improving the way we conduct elections. So now let us look into why blockchain is needed. Next slide. Blockchain's features are generally crucial for voting systems. Decentralization ensures no authority can manipulate the process, and the immutability feature protects against tampering, and transparency allows for an open electoral process. Our project uses blockchain and smart contracts to develop a reliable election system. By replacing the traditional paper ballots, we aim to revolutionize the voting process and we aim to take it to the whole new level. And also our system incorporates business logic and tokens that enhances security and authenticity. It also addresses the issues of traditional system and improves election transparency and credibility. So now let us dive into the core components of our application. So in our application, we have three components. The first one is the Solidity smart contract for voting. And this is the heart of our project. And it is a Solidity smart contract that is designed to handle the voting process. And it covers the crucial functions like candidate registration, vote casting, monitoring voting status, and result tallying. This is written in Solidity and tailored for Ethereum smart contracts, and it ensures secure and efficient execution. Now, moving on to the second key component, it is the deployment on the Ethereum blockchain. We deploy a smart contract on the Ethereum blockchain in order to maximize the benefits which are gained through blockchain. And also Ethereum's decentralized platform ensures security and also it is resilient against manipulation. So it is really strong and no one can break it. So and also it ensures transparency and also tamper resistant recording of all the voting activities, which in turn increases the accountability. And the third key component is the user interface, which is really important for us, for the users who would be voting. We have prioritized the accessibility and also the interface provides an intuitive and seamless experience for the voters. And the voters can cast votes securely and they can check ongoing election status and also access transparently recorded results. And also this improves the overall user experience. Now my friend Nitya will explain more about Ethereum network.
Hi everyone, this is Nithyasri. Moving on, let's discuss the Ethereum network, which plays an important role in our application. First of all, Ethereum serves as a decentralized blockchain platform which enables the creation and execution of smart contracts, which are the contracts that self-execute with terms directly coded. This introduction of smart contracts empowers developers to create programmable contracts, automating actions based on predefined conditions. Ethereum's decentralization operates on a node network, ensuring resilience against censorship, and it also helps us avoid the single points of failure. For all these reasons, it stands out as the leading platform for constructing decentralized applications, which are also called DApps, and they provide possibilities that extend beyond basic transactions. With these elements and the capabilities of blockchain technology, our blockchain decentralized voting application aspires to enhance the electoral process, making it more secure, transparent, and trustworthy. The further components of this project will be explained by my teammate Harshitha.
Hi everyone, I'll explain more about the smart contracts method developed by us. The smart contract governing a decentralized voting application comprises essential functionalities where first comes the candidate registration, in which the add candidate function, which allows the owner to add candidates for voting. And currently we are using 5 candidate users to be eligible to vote, and these candidates can only be added by the owner of the application. The second one is the voting duration and status, where get voting status is used to check whether the user has voted or not. If not yet voted, the screen will display the time left for the user to vote, and using the get remaining time function, which will start decreasing once the user has landed on the page after he is logged in into the application. The third one is a vote casting, where the vote function uses the MetaMask address of the particular user and checks whether he is eligible to vote. And if he hasn't already, it allows him to vote. Once the voting is done, the screen will reflect the voting status of the user as the particular user has already voted. And the result tallying function, where we use the get all votes of the candidate function, provides a view of the increased voting count of the candidate simultaneously once the user is voted. And we have designed interface which is very user friendly, and all the information is easily available on the page. So this is the user interface of the application. Once the user logs in using the MetaMask address, he will be able to see his account address, and the remaining time left for him to vote is shown on the application page. And the all the information about the vote candidates available for voting are displayed here, and he can vote to any user using his index id. He can enter the id here and just click on the vote button to vote for a particular candidate, and once the voting is done, the status will be updated over here for the particular user. And more of the application is explained in the demo in the later stage. So we'll discuss about the user interface, where ensuring a user friendly interface is important for both user engagement and for simplifying the voting process. So in the progress of our project includes the development of an intuitive front end promoting a seamless user experience. So challenges also occur during the integration with the smart contract, demanding a meticulous solutions for the streamlined functionality. And also security is the utmost important in voting applications, underscoring the ongoing process in implementing the robust security measures. The challenges persisted in securing the user authentication, requiring a careful balance between the accessibility and also the protection. In essence, our focus lied in the advancing the usability and security and overcoming the integration hurdles for an effective decentralized voting application. So to enhance the security posture of the voting application, we are committed to exploring the advanced security measures and regular vulnerabilities are considered, and simultaneously we prioritized accessibility by conducting thorough assessments using different users and also the browsers to be able to access the application. So in future we can implement the features like screen readers and keyboard navigation, making the application more user friendly with relevant accessibility standards. By staying updated with the industry best practices, we aim to create a voting platform that not only prioritizes the security but also accessible to a diverse range of users, fostering an inclusivity and usability. And also coming to the conclusion of the project, we learned a lot about the blockchain applications by attending class and also by collaboratively working on this blockchain voting application. We learned a lot about teamwork and working collaboratively within a team, resolving these challenges that are faced during the development has enabled us to develop our skills and also help to grow our skills as a team player. So we would like to thank all the information that is provided, and also the resources and the communities that are available online, which helped us to gain a lot of knowledge about the course. Thank you, and I will pass on to my teammate Tej Kiran to conclude the demo of the project.
Hi, this is Tej Kiran, and today I'll be giving a live demo for the project that we have built. So, in adding more points to the my teammates what I've said. So we implemented a decentralized voting application using React.js, Ethereum, and Solidity. So this application will communicate with the blockchain using RPC node through hard hat ether.js and MetaMask. So the whole project covers the creation of smart contract and React.js. So the smart contracts stores an array of voters for a specific event, with each voter having a name and a count, and it has a voting start time and end time. So the React application is used to build the user interface, which is front end, and communicates with the smart contract. So this smart contract written in Solidity, it will run on a Volta blockchain, while the application run on the client's side of the browser. So to the smart contract is deployed using hard hat. Um, so so this is the configuration file for the hard hat development environment. So it's specifically designed for setting up Ethereum smart contract development. So this development environment is that it facilitates compiling, testing, and deploying smart contracts. So this here, if you can see, this .env library is used to load environment libraries from env file, and from this we fetch private key and API URL. So from here, and so this specifies as the accounts to be used for deploying and interacting with contracts on the Volta network, and this is the gas limit, and this is the gas price that we have set. And next, moving on to voting.sol. This voting.sol is a uh, it's a simple voting scenario with a owner managing candidate addition, a voting period with timestamps and basic vote tracking functionality, and this is the compiler solidity that we use. It should be greater than this, and this is a main function, and we this is the array of candidates that we use, and these are state variables, and this is a structure candidate. And so this is a modifier only owner, which lets you only let owner to modify anything changes, and this is to add functionals, and these are all functions respective. And moving on to next, deploy.js file. So it uses the ethers library to get the contract factory for the voting smart contract. It deploys the voting smart contract by calling this deploy method. And this deploy method takes an array of candidates and duration of voting period in minutes. So when you run the deploy.js, it will deploy the voting smart contract to Ethereum blockchain with the specified candidate names and voting duration, and then it'll log the contact address to the console for us, for developers. Now moving on to app.js. This code, this is the React application code that we have written here. This code imports necessary dependencies and components from the Ethereum library and the React framework. And so this is a function app. So it is a React functional component that defines the main logic and UI structure for the application. And this is the use effect. It's a hook from React library. We use it for, React uses this to change it in the state, and it'll let give it all the results in a more responsive way. And we have a event handling function here, and which handles changes in Ethereum contract and updates the state accordingly. We'll call it, I think it'll be down here. So this for that. And we have a few Ethereum interactive functions. In all functions, we use this same logic. And what this does is it obtains the current Ethereum provider from the browser, assuming the MetaMask, and it sends a Ethereum request to prompt the user to connect to it wallet, whether it is connected or not, and so on. And moving on to, we have this connect to MetaMask. It connects the application to user MetaMask. It retrieves the account. First it will check whether we have a MetaMask or not. If not, it will throw an MetaMask is not connected detected error, and then it will get the information from from MetaMask account details and this everything about this, and it will update it to set is connect, set connect. So these are methods we initialize with useState, and then we use this to update these variables in the functions. And we have a so what this application returns is basically our UI rendering this one. It will return either one of these three components which is connected finished and log in these three JSX files. So it depends, it returns based on different components based on values of voting status and is connected. These components receive various props to display information and handle user interactions. So these these three are the ones that I just said. So these three these three front end pages require each pages require its own props. This login page requires connect wallet, and this connected george js requires remaining time account. All this, based on that, it will display the information. Now we'll run the application and see. So first we'll deploy the js file, and we'll update the contact address in environmental environment file and in constant.js file. So this is the file where we use contact address and ABI to export it to app.js. You can see the export thing here. Now we'll start the application. So this is the login page. So this .jsx is responsible to display this page. So when we connect to log into MetaMask, I think it got connected already from our previous thing. So now after connecting into MetaMask, it will redirect it to connected.jsx file. This is what we are seeing here. So we'll try to out a person now. So let's out to index one. Now I click on out. Now it will go to connect to MetaMask again, and it'll ask us to confirm the transaction it's going to take, and it will take this much gas price. It's in VT currency. Now, since it runs on blockchain, it will take some time to get it updated. Now we can see the candidate Otis one, which we have just voted. So we can see the status that you have already voted for this. So if I want to vote another person, I can change the account here in the MetaMask. So you can see this. Since we have changed the account, we can vote again. So let's go to a different candidate. I'm selecting index 3. Now it will connect to the MetaMask again. Form. It's taking a little bit more time than usual. Now we can see the Christopher Kim has vote 1. It says you have already voted. So this is it. This is a application that we built together as a group. So thank you so much. We are Blockchain Builders Group, CSE 598 blockchain technology. Thank you so much.